Hi fellas, this is Chemaddicts again to the solution. Okay, so now we're gonna solve the next question of this question paper. Okay, so if you have missed the previous solution, don't worry, I'll put the link at the end of this tutorial, so stay tuned till the end. Okay, so now let's solve this question. So four compounds that contribute to global warming are carbon dioxide, methane, dichlorofluoro, methane, sulfur hexafluoride. Okay, so the first question is which of these molecules is polar? Okay, which of these molecules is polar? Okay, is it A, B, C, or D? So before answering this question, we need to first analyze the shape of the molecules, since the polarity of molecules depends on the shape of the molecules. Okay, so how molecules are arranged, it depends on how molecules are arranged. Okay, so now let us analyze each of the structure of these molecules. Okay, of these carbon dioxide molecules, methane molecules, whatever, etc., etc. So let's see at first. Okay, so first thing first, let us write down the mm, uh, what should I write? Okay, let us first write down the formula of molecules. Okay, that we would try. One is carbon dioxide, and okay, okay, at first let us try to draw the structure of carbon dioxide molecule. So the structure of carbon dioxide, since there is two atoms, so the structure of, sorry, since there is three atoms. Okay, so okay, since there is three atoms, and the, what should I say, yeah, so the structure of the molecule depends on the arrangement of electrons. Okay, bonding electrons, electron pairs, it depends on the electron pairs. Since carbon dioxide has no empty electron pairs left, lone electron pair is left. Okay, so carbon, the electron pairs around carbon is 2, so these two electrons are bonded to oxygen, so this makes the shape of carbon dioxide molecule linear. Okay, so the shape of carbon dioxide molecules looks like this. 2, since there are two bond pairs around this carbon, so this looks like this. Okay, so the shape of this molecule is linear. I can't even spell linear. How funny, how ridiculous. Let me check the spelling of linear. Okay, Linear. Okay, linear. The shape of the molecule of this molecule is linear. Okay, so yeah, the shape of carbon dioxide molecule is linear. Now let us try to find the shape of methane molecule. Methane. So at first let us try to write the formula for methane, CH4. So now let us try to draw the structure of methane molecule. Okay, so center we have carbon, and here we will have one hydrogen, 4 hydrogen around this carbon atom. So here the structure would look like this. Okay, then another is like this, so it's tetrahedral in shape. Okay, so it's tetrahedral in shape, so it's tetrahedral in shape. Okay, so it's tetrahedral. tetrahedral. I do believe that my spelling is right. This is R, by the way. So this is tetrahedral in shape. Okay, we have just found the shape of carbon dioxide molecule, which is linear, and the shape of methane molecule, which is tetrahedral in shape. Okay, so we are drawing the three-dimensional shape of molecules. Okay, sounds like nursery. Grade 1. Oh, by the way, grade 2. Grade 2 children. Since in grade 2 we get familiar about different shapes: triangle, circle, sphere, etc., etc. Good old days. Okay, now let us draw the structure of what? Difluoromethane. Ooh, that's look spooky. Difluoromethane. Okay, so the molecular formula for difluoromethane should be like this. Methane, since it is methane, so here we will have one carbon molecule, sorry, carbon atom. So dichloro means here we gonna have 2 chlorine, and difluoro means we gonna have 2 fluorine. So the the molecular formula would look like this: CCl2F2. Okay, now let's draw the structure of CCl2F2. Okay, so CCl2F2 look like this, similar to this methane, tetrahedral. Okay, since uh, this carbon atom is surrounded by 4 atoms, more specifically 4 different groups of atoms. So here atoms, 4 different atoms, sorry, my mistake, 4 different atoms with relative to this. Okay, here we have all atoms that are attached to this carbon atom is same. Okay, here all the hydrogen is attached to this one carbon atom. In here we gonna see that this carbon atom is been attached to 2 different atoms. Okay, let's see how. Let me draw it little down. Okay, my C doesn't look good, really sorry for that. Here let me draw it best that I could. Okay, I'm trying my level best to draw this cooler, to look cool. Okay, so here we're gonna have 2 chlorine atoms attached to this and 2 fluorine. Okay, it doesn't look cool, isn't it? I don't know, let me know in the comments below. Okay, how was it? Okay, here we're gonna have the similar shape as methane molecule. Okay, so here the shape of this molecule, which is dichlorodifluoromethane, is tetrahedral once again. Okay, again spelling mistake, I'm doing the same mistake once again. Tetrahedral. I should learn some spellings. I know I'm not a good person. I really makes a lot of mistake during my solution, and I really appreciate that you still watch my solution. It's mean a lot to me, fellas. I make mistake and you watch this solution, this crappy solution. I know it's crappy. Well, fellas, I'm trying my level best to convince you for the solution. Okay, so here let us compare this molecule with this molecule. Okay, so here the similarities between this molecule and this molecule, which in this case is methane and CCl2F2. Here in CCl2F2, here carbon is attached to 2 chlorine atoms and 2 fluorine atoms. Okay, but in CH4, well, let us at first find the difference. Okay, so the difference between CCl2F2 and methane is, here carbon is attached to 2 different atoms. Okay, in this case carbon is attached to 2 chlorine and 2 fluorine. Okay, as you can see over here. And in the case of methane, we can see that here carbon is attached to all hydrogen. Okay, here all the atoms that is attached to carbon, here all the atoms that is attached to carbon is hydrogen. Okay, here all the atoms are hydrogen over here. Here this is hydrogen, hydrogen, H, hydrogen, hydrogen. Okay, so that's the difference. And the similarities is the shape. The shape would be tetrahedral. Okay, since there is no lone pair, all of the electrons are in bond. Okay, this electron is being bonded with chlorine, this electron of carbon is bonded with chlorine, and this electron of chlorine is bonded with fluorine. Sorry, this electron of carbon is bonded with fluorine, this electron of carbon is bonded with also bonded with fluorine. Okay, so both of them will have the same shape, that is tetrahedral, since all the electron pairs over here is bond pair. Okay, that's the reason. So that's why the shape would be tetrahedral. Okay, so now let's draw the next one, which is what it's called, sulfur hexafluoride. Oh, more spookier. So here the formula of sulfur hexafluoride is SF6. Okay, and its structure is a lot more weird. Okay, spooky. It's look like ghost. Well, let's try to draw the structure of molecule. Okay, molecular structure. So here in the middle we're gonna have sulfur, since we have only sulfur over here. So one atom over here is sulfur, so sulfur will be in the middle, and in its diagonal we're gonna have fluorine. Okay, F. Here we're gonna have fluorine. Okay, so this is a square planar, as you can guess, and above we're gonna have fluorine over here, and below we're gonna have fluorine. So that's the uh, shape of this molecule, which is what it's called, octahedral, I guess. Yes, octahedral. Tetrahedral, octahedral. Okay, I don't know the name of this shape, but the shape has a square planar. So here this is a square planar shape. Okay, so here we gonna have a square planar, and one atom is attached above this square planar, and another atom of fluorine is attached below this square planar. That's how it's look like this. Okay, so here, yeah, this is octahedral. So the shape of this molecule is octahedral for SF6. Okay, so here now let's go to the question. The question says which of these molecule is polar. So in order to find whether the molecule is polar or not, we're gonna look at the net dipole moment of the molecules. Okay, so we're gonna check the net dipole moment, net dipole moment of the molecules. Okay, so here let's study the net dipole moment of the molecule. Okay, So here in the case of carbon dioxide, here the net dipole moment would be 0. Okay, so here we're gonna get the net dipole moment of this molecule would be 0. The net dipole moment of this molecule is 0. Okay, since the molecule is symmetric. Okay, so since the molecule is symmetric in the case of carbon dioxide, the molecule of carbon dioxide is symmetric. Okay, so that is why the net dipole moment would be 0. So here the net dipole moment would be 0. Okay, so we don't gonna get the polar characteristics in the case of carbon. So that is why carbon dioxide is not polar, since the net dipole moment is 0. Okay, now let's look at the case let's look in the case of methane. Okay, so here since it is tetrahedral, okay, the net dipole moment of methane would be 0. Okay, so here the net dipole moment would be 0. So therefore the net dipole moment would be 0 in this case also. Okay, since we gonna get the symmetric molecule, since this is a symmetric molecule, and yeah, we have a same, what it's called, same atom around this carbon atom. So that is why that makes the dipole moment of this molecule 0, and it's also the shape. Okay, so generally if we have the same atom around this around this carbon atom, same atom in this case, if we have all the atoms that is attached to this carbon atom, okay, in tetrahedral shape, then we're gonna get the net dipole moment 0. Do I clear my point? I hope so. So here in the case of tetrahedral shape, so generally in tetrahedral shape we get net dipole moment 0. Why? That's because here carbon is been attached to 4 different here carbon is been attached to same atoms. Okay, here hydrogen. So all of the atoms that is been attached to this carbon is same, in this case hydrogen. So that makes the net dipole moment 0. So I hope that you have understood. So now let's look at first SF6. Here once again the net dipole moment would be 0. The net dipole moment would be 0. Okay, so SF6 molecule will have net dipole moment 0. Why? That's because the shape is octahedral, and once again, just like methane, all the atoms that are attached to sulfur is fluorine. So since all the atoms that are attached to sulfur is fluorine, so that's make the net dipole moment 0 over here. And once again the net dipole moment also depends on the shape of the molecule. So here since the shape is octahedral, the net dipole moment would be 0. So here we have learned one thing, that if the molecule have octahedral or tetrahedral structure, then we gonna get net dipole moment 0. The only condition is that the center molecule should be attached to same atoms. Okay, here it is fluorine molecules, all the fluorine molecules is been attached to this sulfur. Okay, in this case all the fluorine atoms is been attached to this sulfur, so that's make it octahedral, and this is why the net dipole moment would be 0. and in this case methane, all the hydrogen atom is been attached to this central carbon atom, and the shape is tetrahedral, therefore the net dipole moment would be 0. Okay, net dipole moment would be 0. Now let's finally look at this structure of this molecule. So in this case, the shape of the molecule would be same, tetrahedral. The only difference is here carbon is attached to different atoms. Okay, two different atoms. One is chlorine, carbon is attached to two chlorines and two fluorine. Okay, so here this makes the net dipole moment not 0. Okay, so in this case the net dipole moment is not 0, it's something else. So the net dipole moment is not 0. Okay, so that makes the case. So the net dipole moment is not 0 over here, since the different groups of atoms are attached to this center atom. Though the shape is tetrahedral, but still the net dipole moment wouldn't be 0, since different atoms is been attached to this center carbon atom. So that's make the difference. Okay, so in here the the options here is A, this is A, this is B. Okay, methane B, then dichlorodifluoro, what does this say, I don't know, blah blah blah. So this is C, and this is D. Okay, so here in option A, B and D, in option A, B and D, we can see that all molecules are symmetric. Okay, so and have net dipole moment 0. Okay, so here in option A the molecule is symmetric and the net dipole moment is 0. Okay, so that is why this molecule in this case is carbon dioxide. This carbon dioxide molecule is not polar. Okay, in the case of B, this same goes with B. Okay, here since this molecule is symmetric, all the atoms that are being attached to the central atom is hydrogen, so that makes the net dipole moment 0. Okay, in the case of C, here here we can see that different atoms are being attached to this central atom, so that's make the net dipole moment not 0. Okay, not 0, not the value 0. So in the case of SF6, here we can see that this molecule is symmetric, and in here all the atoms that are being attached to this sulfur is fluorine. Okay, so that makes the net dipole moment 0 once again. So fellas, I hope that you have understood the difference, the main difference, the main speciality of this molecule other than this other molecules. Okay, this molecule is special, that is why this molecule is special, and we need to choose this for our answer. Okay, so now let's pick up the correct answer, appropriate answer, whatever you say. Okay, so let's do it. Yeah, so here the answer should be C, dichloro. This guy has won the answer. Okay, this guy has won the internet. So here the answer should be C. Okay, okay, so the answer should be C. which of these molecule is polar. Okay, so fellas, that's the end of this solution. Okay, so here the answer should be C, as you can see. So the answer is C. Okay, this molecule, let me draw this once again. Cl, Cl, F, then this is Cl. So sorry, not, this shouldn't be Cl, this should be F. Okay, so this molecule has won this answer. Okay, though, so here the answer is C. So fellas, the time has the time of this video is pretty lengthy. The time of this video is being lengthy, so I don't want to proceed to the next question. So in the next question we're gonna solve this problem. Okay, so let's leave it for next solution. So fellas, I hope that you have understood the solution as well as the question and answer of this question. So fellas, I hope that you have understood this question as well as the solution. So if you have any question regarding this solution, please let me know in the comment section, and I'll put the previous solution, the video of the previous solution over here. Okay, so click anywhere here, the video, the link to the previous solution would be here. Please click it anywhere here, over here. I'll put them here. Okay, so until next time, stay cool, stay awesome, best of luck for your exam, and as always, peace with chemistry.